Now let us see how we can prepare galvanic cell from the help of electrochemical series. As I have told you, we can select any two electrodes, we can connect them. Definitely the one with the lower E0 reduction value will become what? Anode, because that will get oxidized, and the one with the higher E0 reduction potential will become cathode, and this is how the cell will start functioning. A spontaneous redox reaction will take place and overall voltage output will come out. Now in the galvanic cells, the overall output of the cell is called cell potential, or in simple language we can call it potential difference, whose symbol is this E0 cell. Now this E0 cell must be the sum of the oxidation potentials and the reduction potentials of the two half cells. But we know now this oxidation will behave as an anode, this reduction will behave as a cathode. So I am using A symbol for anode, C symbol for cathode. But we know we all take all E0 values in terms of reduction. So we will change this as a negative of E0 reduction, but it will keep on behaving like anode, and it will be E0 of reduction, it will keep on behaving like cathode. So this E0 cells, the new formula will become like this. It will be your cathode minus anode. Remember, all E0s will be your standard reduction potentials. So the formula is E cathode minus E anode, which we can also write E left minus E right minus E left, because always we keep anode on the left hand side and keep cathode on the right hand side. But this is a very simple way of writing down this formula, and this is how we can add up the two half cells values and we can find out the actual potential of the cell, which is called potential difference. There is one more term which we often get confused with this, which is also called, this cell potential is also called electromotive force, in short called EMF. Remember, it is the cell potential or the potential difference between the cathode and the anode when no current is allowed to flow in the circuit, or no current is flowing when the circuit is open. So that's the maximum potential we can have. Its value is determined by using potentiometer, but the moment the circuit is closed, the current is flowing. A part of it is used to cover up or to overcome the resistance of the circuit and the system, and that is why the potential difference comes out, which is actually slightly value less than the EMF, and it is the one which we actually measures, or we come to know from the voltmeter. So this is what are the terms are, and we can use this formula to find out the E0 cell of any of the electrodes. Let us see the examples of how we can find out the cell potentials of the galvanic cells. It's given in the form that find E0 cell for the following. The first is, we are given these two electrodes with their E0 reduction values. We know, if suppose we have to see before we're moving into the formula, if these values are given in the form of oxidation, we will definitely convert them into the reduction form, so that we can easily use them in the direct formula. We know when we will connect these two, the E0 cell of the cell which is formed by connecting these two half cells or the half electrodes will be E naught cathode minus E naught anode, and out of these the one with the lower E naught reduction potential will behave as an anode. So this will become your anode, this will become your cathode. So your cathode is minus 0.44 and it is minus of 0.76 volt. So it will be minus 0.44 plus 0.76 volt, and this comes out to be, if we do this, it will be 0.32 volt, which is a positive value. So the output of this cell will be 0.3 volt, and this is how we can use this formula for finding out the E naught cell for any possible electrodes which we have got. And now we can make out from in our mind very clearly, like the combinations which we have made of the zinc electrode with SHE. Since the SHE was behaving like with the zinc as cathode, its value was 0 and anode's value was 0.76, E naught cell was 0.76. That is why the anode value, the zinc value, was given 0.76. So this is we could have actually we have used the same formula when we were determining the values of the electrode potentials. But I cannot give you at that stage, we cannot make you to use this formula clearly and directly. But yes, at this stage you can understand this formula and you can use it wherever you want to find out the E naught values of all possible electrodes.